Hi, it's Mr. Anderson, and this is AP Physics Essentials Video 19. It's on electric permittivity, which is best understood when you're looking at capacitance. And so for this video, I created a capacitor out of 3 layers. 2 layers of Reynolds wrap, which are good conductors, and then 1 layer of plastic wrap in the middle, which has a higher permittivity. And so in order to make this work and make it a little bit more portable, I rolled the whole thing up, and so it looks like that. If you look at a real capacitor, it's going to be rolled up, but it's essentially the same thing. You have conductors on either side and then something insulative in the middle. And so let's look at this video for just a second. Right now I'm hooking up my capacitor to a multimeter, and you can see that there's no electric charge on the inside. Now I'm connecting it to a couple of batteries, so I'm adding charge now to the capacitor, and now I'm going to hook it up to the multimeter, and you can see that the charge increased really quickly. And so I had stored charge in just this little amount of Reynolds wrap and plastic wrap. You can see it's kind of discharging now. And so what is permittivity? Well, if you have an electric field like this, matter has an ability to resist that electric field, and that resistance to an electric field is called its permittivity. And so the permittivity of free space would be the resistance offered by just a vacuum between those 2 conducting plates. And so that's a constant value that we can compare other materials to. And so if we have other materials, their permittivity is based on their structure. So their atomic or molecular structure is going to be variable. And as we vary the permittivity, we can make a capacitor that is more or less efficient. And so let's look at a real basic capacitor, and that'll show you the elements of capacitance. This is what they look like today. So if we zoom in like this, what you have are 2 conducting plates on either side. So those are connected with wires. And then in the middle, we have a dielectric. And so that's going to be an insulator. It's something that we can resist that electric field forming in that capacitor. And so if we look at basic free space permittivity, so what we would have in the middle now is going to be just a vacuum. And so what we do is as we hook it up to voltage, you're going to see that there's an electric field across that gap. And that's the free space permittivity, or sometimes we refer to it as the dielectric constant. And so for a vacuum, it's going to be 1. Air is going to be slightly higher than 1, but it's going to be pretty close to 1. And so what happens when we add a dielectric in the middle? When we add an insulator in the middle, well, that's going to be made of atoms, and atoms are made up of protons and electrons. And what happens is as that field moves through the dielectric, what it does is it shifts the electrons. So the electrons are actually being shifted, in this case, to the left. And that creates an opposite field, which cancels out that electric field. And so if you add a dielectric between these 2 conducting plates, what you're doing is resisting that electric field. And what that does is build up a charge on either side. And that's how we're storing that energy. And so we now see that we have a dielectric constant that's going to be higher than our constant, which was 1. And so if we look at this PHET simulation, we have a capacitor here in the middle, and so we're going to add a little bit of voltage to it. And you can see that charge is starting to build up on both sides of that plate. Now if we take a dielectric and slide it in the middle, well, this dielectric is just free space, and so you can see that it didn't change the capacitance. But if I start to increase the permittivity, watch what happens to the charge on the plates. So now we're at 2, and now we're at 3, and now we're at 4. You can see charge is building up on the plate. And each material, Teflon 2.1, paper 3.5, glass 4.7, is going to have a different constant. And if I pull that dielectric out, then our capacitance drops down to 0. And so did you learn that electric permittivity increases resistance in the electric field? We can use it to make a capacitor, which could be made simply out of Reynolds wrap and plastic wrap. I hope so, and I hope that was helpful.